Hello friends, welcome to my channel Code Destination. So as we are continuing this topic binary search algorithm, so yesterday I discussed about the binary search algorithm, how it works and how we can understand the logic behind this. So today we will continue this topic as well, and we are continuing our this challenge, one code one day. So basically today we will take a one variant of basically binary search. Basically we will use binary search in that question and we will solve that. So for today we are taking this problem like implement upper bound and implement lower bound. So like we will think how we can use the binary search to finding the lower bound and upper bound, and at the last we will solve this LeetCode question. LeetCode I think, yeah, question number 34, find first and last position of the element in the sorted array. So let me share my screen to, yeah, yeah. So first we will understand how we can find the lower bound using binary search. So for that let me take some example. So I'm taking one array, 1 2 3 5 8 9. So suppose I'm taking this array which is sorted, because we can apply a binary search in the sorted array only, as I discussed already. And suppose I am going to find the we have given some x variable, suppose some number, suppose 2, and I want to find the like what is the lower bound of this number, like in this case 2. So here in the problem statement also mention in the note, for a sorted array lower bound of the number is defined at the smallest index such that the value array is not less than x. It means that array index value should be greater than or equal to x. So how our lower bound define any array element, like in this array element, if it is greater than or equal to x, so that ith value is define our lower bound. So how we can think, so let me visualize this. So how we can visualize, suppose I make on graph, suppose I am starting from here 1, and that is the 2 value 2 times. Okay, after that it is increasing till 3 value. So here there are 2 value of 3 in the array, first second. After that it again increasing till 5 here, then 8, then 9. So suppose I just draw that lines to represent this array value, because we already know this array is sorted. In that case I can apply binary search, and in the question also mention here array is sorted in the non-descending order, it means at ascending order. So how we can think, so as we already know, like in every binary search we generally define the range, like boundaries, using this start or I variable, anything, and this j variable, it represent this boundary, like our this start and this end boundary. Okay, so in that case generally we calculate middle value, like using this I and j, and we compare the value which is given, like this target value. If it is less than, then we shift our boundary to the right side, and if it is like greater than the middle value, then we shift the left side. So it is a general approach. So suppose in this case I draw this number in the uh, graph manner, and we can assume different cases where our middle can lie. So suppose I considering suppose I am finding this two one. So if I take this 2 as a number and I want to find the lower bound, so in that case the output should be this one, because this is the less than, sorry, greater than or equal to, so it is a equal to value. So that is, so that should be our output. And in the example we can also see like if any element, like it is given, so if the number is 2, then for that output is 1, because as a definition it is saying that ith value of array, ith value should be greater than or equal to. So in this case, like it is 2 is equal to 2, that's why it should be the answer. Okay, so how we can approach the problem? So for that, suppose this is the ith variable which define the lower bound, and this is the jth variable in the binary search we generally use. And our middle can lie anywhere. Like suppose I am taking the one example, suppose it can lie here. Let me visualize it. So my middle point can be lie here. Okay, there are various cases, so I am just taking the corner cases from here. Suppose it can lie here. Okay, it can also lie here. Okay, and it can lie at this line as well here. Okay, and we already know what is our answer. So our answer is this 2 which is present here. Okay, so let me mark it. So basically we want to find this value using binary search. So what we can do, we can just define the different cases. So as I already defined, suppose I define this is the case 1, this is the case 2, this is the case 3. Okay, this is the case 4, and we will observe in all cases what we can do. So like if our middle value, suppose middle value lies in the case 1, so what we have to do, basically we have to switch and the left side. So basically I will switch here this side because my answer lie at this point, correct? Okay, and if I lie in the case 2, suppose my middle lie here, so where I have to sit, my answer is here, so in that case also I will have to sit left side. And if my middle lie in the case 3, so in that case I have to also switch in the left side because my answer here present. And it is a corner case, so it is covering that equal to case, because if this 2 is equal to my this 2 like target value, so in that case this case 3 happen. In that case also I have to switch the left side because maybe there are some value in the left side which is equal, so that index I have to find, because that is our lower bound, and our lower bound defined in the equal case as well. So I have to just find the lower index in the equal to case. So in that case, if that case 3 happen, like if any value is equal to my target value means x value, so in that case also I have to shift the left side. And the case 4, my if my middle lie anywhere, so in that case I have to switch, like I have to shift right side. So basically same approach I will follow as we visualize in that all the cases. So just we will take two variable I and jth variable, and we will find the middle, and we will define all the possible conditions for all the middle. So I think it helps as we visualize. So same manner we will write the code, so you can connect the code with this logic. So just for finding the lower bound, what I did, just I defined two variable is 0 and j the upper bound. So array dot length -1 is my upper bound and lower bound, and I will run till my I equal to j, because as usual we did in the binary search, correct? So in every loop I will find first middle point, so I plus j minus I by 2, so I can find the middle value like this. So for every case we will write the conditions. So for first case, suppose my target value is x here, so if my x value is greater than array of m, so it is which case, if my x value, like my area of middle value is less than x, so we can see here if my array value is less than x, so my x is 2, so like my x lie basically in this range. And basically this is the case for this case, if my any value like in this range, any value is it will be the less than this value, correct? So in that case I have to switch the right side. So how I will shift right side, basically I will shift this I pointer to after that middle pointer. Suppose my middle is here, I have my middle is like here, my middle value, any of middle value is less than x, so in that case I have to switch this I to the after the middle, so my I will shift here. Okay, I will shift after the middle because that value lie after the middle, so my middle plus 1. Okay, same manner I will write here, so my middle will shift after that. So in that case what will happen, okay, so my I will be shift m plus 1, In that case, in the else condition, if like suppose my x value is less than middle value, in that case this is the opposite case, so I have to shift right side. So for shifting um, right side, what I have to change my upper bound range, so I will take j just before that m in that case. And if any equal case happen, so in that case what we can do, in equal case as well, what I have to do basically, in equal case, if it is equal, I have to shift my left side. Okay, so for shifting the left side, what we can do, mm, I can shift my basically middle point to the left. So what I am doing here, let me show you. Suppose my middle lie here somewhere, uh, suppose here it is lie. Okay, so my, if my middle will be here, so I have to shift left side suppose. So what I have to do for shifting the left side, so I will just make my upper bound like j index to the left, so my j can start from here. So I will shift my j equal to m minus 1, so my j will shift left side because we are approaching towards this answer. Okay, so my j will shift left side in this case. Okay, so in this way we can just approach towards my answer. And for getting my answer, maybe I will use my one variable which is initially defined -1. Okay, and when I will update my answer in both case, like because I mentioned in starting as well, like if my area, if I value is greater than or equal to x, so in both case I will get my answer. Okay, so in both case, like if my area of m is greater than like x, in that case um, what I have to do, basically I have to monitor my answer as well. So I will just take middle point as answer, and if my like in equal case as well, I have to update my answer, so I will take middle here. So in this way I can store my answer. So at the last, what I have to do, I have to just return my answer, which is my result. Why we are updating, basically in every case, like here I can show you. In every case, like if my value is greater than, like if this value is greater than x, so like in all these cases, suppose here till here to here, all this case my answer is updating. Suppose here somewhere I am, so my answer will be something greater than that one. Suppose in that case 5, at the 5 index, so my answer will be 5. But again we are shifting left side, so my in the equal to case my answer will be like in equal to case 0 1 2, so I am 2 index, my answer will be 2. But again we are shifting to the left side, so in equal to case also I am updating that. So at the last, in my answer, in the answer I will get 1. So in this case I am monitoring my answer as we are approaching toward the answer. So let me run it. Yeah, so it is giving some error. Let me see why. Okay, so if it is finding the 0, in that case what it is giving, okay, for 0 it is giving the -1, which should not give. Okay, why, what we are doing wrong? Suppose if my x value, my answer like array middle value is less than x, so in that case my I, it is correct. And if it is less greater than, okay, greater than x, so my j is shifting towards left side. And in equal to case my answer is also updating, and my j is shifting to the left side. Okay, that is looking fine. Okay, but in that case, oh okay, because it is actually 4, sorry, it is 0. So in that case, What is happening here? Suppose length is here 3. If my x value is greater than uh, so that is not a case. Here my variable is also defined correctly, and my this variable is also defined correctly. Then what is going wrong here? Maybe I use some wrong variable somewhere. No, I guess. Yeah, that is fine. In else case as well, it is fine. What is wrong here? I don't know. Okay, maybe I can like check separately. If that value is -1, it means we didn't find that value. So I can return the first index, otherwise the answer 1. And here one case I also covered. I can like think, if my array is sorted, suppose any number is given, like in this case 4 is given, so in that case I have to return the like fifth index. So if my last value um, array dot length -1, last value is greater than my x, so in that case I have to return directly here, and because that is not present in the array, so it is, I think, corner cases. So let me run it again. Okay, that should be int. So what is this doing? So my x value is okay. Actually, x should, if x is greater than that last value, not less than, so that is to be reverse. Let me check again. That case, that n will be the output. Yeah. So that in the basically I covered these corner cases. If my like in that case, if this suppose here 4 is given, so if 4 is like greater than all the element, so in that case the last like size of we are returning 4 returning, because this is 3. And if my like x is greater than the last value, so I have to return that only the index last, like out of the bound index, like here in this case the 3 index is the last index, but I have to return 4. And the second corner case, if we didn't find the element, like, so it definitely belong, like suppose in this case, suppose it is given 0, so in that case it is not belong, but it is we have to return the 0 index, because like one is the L equal to like greater than 0, so in that case I have to return 0, not -1. So we just covered these corner cases separately. So let me submit it. Yeah, yeah, so we can see it is accepted. So I hope you understood. There were some corner cases which we covered separately, but yeah, that is fine. This 0 and last in like last element. So like as we discussed already in the logic, we just covered all the cases, because this case I think this case 2 and 3, like case 1 here, case 1 and 2 is lie, like if the like middle value is greater than x, so that's case. And case 2, 1 and 2 lie in the this case, if my middle value is greater than x, so it is case 2. And this case 4 lie if my middle value is less than this one, so middle value is less than x, so this is the case 1. In that we are shifting just right side, and in that case we are just shifting left side using the pointers, upper like lower and upper boundaries. And in equal to case, we are just updating my answer, and we are shifting the left side, because in the equal to case basically we have to focus. If it is a equal to case in the case 3, so in that case also we have to shift the left side, so we are shifting the left side. So for finding the lower bound, we are just implemented the logic, and it is working. So in the same manner we can think about the upper bound. So let me quickly open that. So in the upper bound, what is the condition? In the note it is written, the upper bound in the sorted array is the index of the first value that is greater than a given value. So in the upper bound basically that should be greater. So what we can think here, basically let me change it. 1 2 2 3 3 5 8. So if it is 1 2 2 3 5 8, so let me draw it. 2 2 3, okay, 5 and 8. Okay, so suppose I just consider like that: 1 2 2 3 5 8. So upper bound is greater than, we can see in the definition here in the note, upper bound is the sorted array first value that is greater than a given value. Suppose here the x value is given 2. So in that case, what is the upper bound? Upper bound will be the greater than value. It is not this one, not this one, it should be here. So in that case, in the, I think, example, it also mentioned, like suppose this is 7. So for 7, like in the array we can see this here 147, 147. So it is matching with the 7, but the upper bound is strictly greater than that value. So in that case, the value is 8, which is the upper bound of 7, so that index is 3. And in the second example, we can see if it is 10, so it is just equal to 10, so we have to return the upper bound, so that should be the outside of the array. So 0 1 2 3 4, 4 index, but that 10 is equal to, so I have to return the, like, upper bound, so that should be 5 fifth index. And in the third example, for fifth, that should be 7, 7 output, and the index is 7 is 0 1 2 3. So basically we can understood upper bound like this. So how we can approach in the same manner? So we know like our answer is this one, this 3, if we are finding the 2. So same manner we will approach. As I approach a lower bound, my I is here, my j is here, and my middle, for middle I will define the cases. So first case should be here, second case suppose here, anywhere it is equal, and the third case is this one. Okay, so for every case I can define this case 1, this case 2, this is the case 3. So basically we are approaching here. So suppose my middle is here in the case 1, so where I have to switch, basically I have to shift left side. And if my middle is in the case 2 or case 3, in both case I have to shift right side. Okay, because if it is like equal as well, like if this x value is, we are searching this x, so we are finding the upper bound of this x, so we are passing this x. So if the x value is equal to the middle value, so in that case also we have shifting the right side. Why we are shifting? Because we are because the upper bound is strictly greater than, not equal to. So we are still, like suppose we are here in the corner case, it is equal to 2. In that case also we have to shift the right side, because we are searching this 3. Okay, I think you understood. So same logic we will apply as we applied in the upper bound. So maybe I can just copy this internal part from here. Okay, so I just copy that same code here. Okay, so I just remove the corner cases, maybe because that corner case is for lower bound only. I can return answer here only. Okay, and yeah, so for upper bound what we can think, like I just make the loop, I just find the middle value same, and if the middle value is um, less than x, so in that case I am just shifting the right side. And if it is middle value is greater than x, so in that case we are just shifting like left side. Okay, and in equal to case, if it is equal, we are like updating our answer. But in the upper bound case, what I said, for any like j value, upper bounds value should be greater than x, not equal to. Like previously for lower bound it should be greater than or equal to x, but in that case it should be strictly greater than. So in that case, in equal to case, we didn't we need not to monitor the answer, so I just remove this answer, no need to monitor it. Okay, and what can be the corner case here? Maybe I can write the corner case, like if my array last value last value is suppose less than or equal to x. So in that case what I have to return, I have to just return an value. Like suppose in this example we can see if that 10, like in this example if 10 is here and we are searching a 10 again in the example, so what it is returning, it is returning the n value like 5. So same case I am handling here. If my x value is greater or suppose it is given here 11, 10, 11, 13, anything, in that case I have to return the fifth index, like in this case. So that case I just covered here in that corner case. So let me run it. And other thing is same as the lower bound, but in the lower bound we was also updating my answer in the equal to case, but here I remove and we are updating only the answer when the middle value is greater than m. So let me run it quickly because it is almost same logic, just one condition change. So we can see here all the test case pass. Let me submit it. So I hope it will run. Yeah, so for large test cases check also run. I think it is failing for some cases. So where it is failing, let me see. So my answer is -1 here. We are calculating the middle value. If my middle value is greater than x, so answer we are updating. Okay, and in the equal to case, oh okay, I think this case is wrong because, okay, let me show you as I explained. If it is equal to case, like in the lower bound what we are doing, if it is equal to, we are shifting right left side, because in that case that was my answer. But if it is equal to, in that case we have to shift the right side. So like in lower bound I copy paste it, so we are like, if I shifting my like high and boundary, like last boundary with the left side, but now we want to shift it right side, so I have to shift just m+1. So let me run it again quickly. Oh sorry, I made something wrong here. Okay, what it is going, output nothing it is giving. Why? Oh, it is possible actually, should be given something. So in that case, like in else condition, I just, oh sorry, I have to set my I pointer in that case, otherwise it will go loop. Because like, why I am doing this, because we are shifting the we are shifting in the right side, like, so for shifting the left side we are just moving my this j pointer here after, like just before the middle. But for shifting the left side I have to set my I pointer. This I pointer should be, like suppose I am here, my middle pointer is here, I am somewhere here, okay, my middle, and my area of middle value is like equal to 2, so which is equal to x. So in that case I have to shift the right side. So for shifting the right side I have to move this j I pointer here, so my I will be m+1. So not j is equal to m+1, that's why it was just failing. Let me submit it. Yeah, definitely it will run now. There was some change regarding logic, so I forgot to change this equal to case. So now it is accepted. So you can understood, like same logic we applied and almost same code, just some corner cases we handled. And in equal to case we just shift the right side in this upper bound, and in the lower bound we just shift the left side. So if I combine this both code, maybe just for lower bound and upper bound we are just shifting left and right, so we can just introduce one variable here. So just I trying to combine both code. So suppose for first index I combine true, so suppose in this case it is false. I'm just trying to combine both the cases in the one code. So for that what I can do, I just introduce this variable here. Okay, so in this case it is true because we want to shift this to the like left side. So if it is true, if my first index this variable is true, so in that case I have to just shift it to the left side. And in else condition I can write uh, shift my I variable m+1, like right side. Okay, so with this only variable we can just like write this to both same code, and in the same manner I can just copy it. Okay, boolean fi variable here, so it is false in this case. In the false case it will run the else condition only. So why I am writing, I will just show you after some time, but for now I am just writing it. Like in this case it is false, so it will just shift the right side. Okay, and in the lower bounds case it is true, so it is shifting the left side. So, and we are also updating the answer in that case, equal to case. So I am trying to combine both codes so that we can use same code everywhere. Okay, so let me discuss quickly this question from LeetCode now. So in this question almost everything is same, but what it is written here, let me read it. So we have given the array, and like suppose any target value 8. So if this 8 lie in the array, so we have to just return a lower bound, like lower index and higher index of that for particular element. Like for this 8 element, the lower index is 3 and the higher index is 4. And if that index, like this element, is not included in this array, so in that case I have to return just minus and minus. So I will use same code, like as I found the lower bound and upper bound, I will just change some minor logic in that case. So maybe I can copy it from here. So how, by this example you can also understood how we can use same logic everywhere. So suppose I copy pasted here, and I will write his find index. Okay, find index, and just this is the my method. Okay, so in that method what we have to do, basically we are not finding any lower bound or upper bound. We are just like in equal to case for first one, like for finding the first index we are just shifting left side, and for finding the like second index we are just shifting right side in equal to case. Okay, so same I will do here. The other thing is same, but in the else condition we are dealing with equal to case. In that case I just like up, updated my answer, and if my like fi value is true, in that case we are shifting left side, and if my fi value is false we are shifting the right side. So just I will pass this fi value in this function here, this fi value. Okay, so with this fi value we can find both indexes, right? Because in equal to case we are updating it, and in this case like less than or anything we didn't bother about that. And in equal to case we just for first case we are just shifting left side to finding this index, first one, and for finding the second index we are shifting right side. Okay, so let me, okay, and this special case also not needed because we are not dealing with lower bound and upper bound. Okay, so we need answer, so I will just make this answer 2 size. Okay, and yeah, so for start index, or finding the start index for that target value, what I have to do, I will use my function find index. It is the same as we discussed in the lower bound and upper bound, and I will pass in that my array. And what is here, yeah, n is my size. Okay, n is my size, so in that case nums dot length, and what is here, x is my target value, so I will pass my target here. And what other thing, yeah, for first one, for finding the first index, what I have to pass here, true. Why I have to pass here true, because when we will pass this fi value is true, so in that case it will be true, and it will shift the my j pointer left side, because we want to find the left index of 8. So it is not a lower bound, but yeah, for equal to case we are just dealing with is else condition and shifting left side, so it will find the in answer it will update with the like this eighth index, basically 3, so it will return the 3 for start. And for and value same function I will use, just shifting some boolean value. So I will pass here length target, and for this case I want to shift right side, so I will just pass false here. And at the last I will store in the result, that is start, and for one of the index I will store and I will return this result here. So let me run it quickly. If it is something failing here, okay, -1 it is failing. Why it is failing for -1 case? Okay, if it is equal to 0, in that case, okay, if its size is 0, what it is doing? Okay, in I think if array value is nothing is having, so in that case maybe I can handle directly here. If my nums dot length value is 0, it means nothing in the array. So in that case I have to just return -1 and -1. Maybe I can tackle that corner case here separately. Another case it will return start and end index. Yeah, so we can see this, all the test cases passed. Let me submit it quickly. Okay, so for 2 and 2, like for 3, 3 is not present in that case. Okay, if length is 0, or one condition as well, if my last value, like in that case, if my last value is greater than our target, okay, in that case as well we have to return the -1 because like suppose my last value is greater than 3, so it means it definitely not present in the array, so that target is not present. In that case also we have to return the -1. So what it is happening, okay, sorry, that should be reverse actually. Okay, it is just corner cases, so we have to just take care about the corner, all the corner cases, because it is in that case it will not run. Yeah, so we can see it is taking 0 millisecond and beats 100% of users. So how you can understood how we can just utilize the same code in here LeetCode problem. So what we did, we just first write the lower bound case and for upper bound case, and for this finding first and last position, what we did, we just think about this else condition. Why? Let me show you, let me visualize it again so that it will be clear. Quickly I will do. So in what is happening, suppose for this example 5 7 7 8 8 10, so 8 is given, so let me draw it on the number line. So suppose 5 is here, then 7 7, then 8 8, and then 10. So what is happening here, like my I pointer is here, okay, and j pointer is here. So what is happening here, like there are several cases. So suppose this is one case, it is here, second case it is here, third case it should be here, okay, the fourth case it should be here. And I know my answer will be the for first one we are passing this true value in the function, as I said. For that it will shift left side, and for second case it is passing the false, so maybe I am considering the true case only. So for this finding this 8, in my answer is lie here, okay. So suppose I am at this position, this case, so in that case I am shifting left side, and if I am an equal to case, so I am shifting the left side, okay. So that condition I just here checked in the, like left side I pass this true, fi true, so in that case my j is shifting the left side, like j is m-1. So if my m is lie here, so my j will be m-1. So I just shift here, like I start from here now. So in this way I am shifting the left side and I will find this index now. But if I am I want to find this index. So for that, in equal to case, we are shifting the right side. So how it is working, suppose this is the same example. Okay, so my jth pointer is here, I pointer is here. So in the second case I am passing this false. So if I am passing this false, so in that case this I will be m plus 1 because we are shifting the right side. So what it is doing, suppose I am here somewhere, one case is happening and we are thinking about this, my answer is this one, and there are some cases, suppose here. So if I am here, so in that case I have to shift right, like right side definitely, and if I am here, so I am shifting the left side. So that is the like greater than or equal to, like greater than or less than case, so it is okay. But for equal to case I have to shift now right side. Before I was shifting the left side here, but now I am shifting the right side. So for shifting the right side, what I have to do, I have to just shift my, suppose I am here, my m pointer is here, so my j will shift now after that here. So my I will be m plus 1. So in this way I will just shift right side and I will just shift and update my answer. So my answer will also update m. After that again I have shift, then again my answer will update m. So till it will update when it will get this 8 here. So now we can get this 8. So in this way, for both case, by just passing true and false, we can get both like indexes. And you can also think how we visualize this lower bound and upper bound, and how we can solve the lead code, this problem 34, find first and last position of element. So I hope you understood this intuition behind this, how we can approach that problem, and how we visualize and build the logic like for the binary search. And we, if I talk about the time complexity, so it is the same because it is almost the same binary search algorithm. So it is big O log n operation, we can see, and in the question also mentioned, we have to just solve it in the log n operation here, time complexity log n. So it is accepted, it means it is the big O of log n time complexity solution. So I hope you like the video, and if you like, please like video on YouTube, and please subscribe my channel so that in future if I upload any video, you can just like understood that problem and you can enhance your problem solving skill. So thank you for watching my video.